Welcome, ladies and gentlemen. So what I'd like to do is just kind of go through a basic description of how to graph absolute value inequalities. Now, as far as the rest of my examples, that's what I'll go through a lot in this course. I'm showing you a lot of examples of me working through some problems. But basically with this, I just want to kind of go through a step-by-step process of what you need to be doing when you're graphing absolute value equations. So when graphing absolute value equations, we're basically graphing absolute value equations and then applying some shading to determine, what's going to be a part of our solutions or not. So the first thing, when graphing an absolute value equation, we have to identify the transformations. How is this graph shifting left or right, up or down? Is there reflection? Is there any compression or stretching that I have for the graph? Through those transformations, we should be able to identify what the vertex is. Remember that the vertex is in the form of h comma k, except when there is a b, which we'll talk about later. But when you have an equation with some transformations here, it's going to be hk, unless you have a bx minus h. But again, that's kind of a different story. I don't want to get too in depth with that right now. But basically, identify your vertex. Where's this new graph going to be? Is going to be from the parent graph. Then the next thing is, if there is no a or b, that means they're not going to have any horizontal or compression or stretching, then I can just graph the parent graph. However, if I do have a number other than the absolute value, or if I have the number that the absolute value is larger or smaller than 1, then I am going to have to use a table. And the best thing to use when using a table of values is just do a table of values for points to the right or to the left of your vertex. Then use the line of symmetry of an absolute value equation and reflect the points that you figured out to the other side, so then you can graph it. The next thing is identifying if your inequality is going to be dashed or solid. And to do that, you just need to look back up at your basic problem. If your inequality is less than or equal to or greater than or equal to, then your graph is going to be a part of the solution. That means all the points that make up that graph are going to make your inequality true. However, if it's less than or greater than, then we are going to graph a dashed line, because any point that makes up that dashed line is not going to be a part of the solution. If we plug them into your original problem, the x and the y coordinates of a point that lies on a dashed line, it would not make the inequality true. The next thing is we need to identify where to shade. All right? And the best thing to do to determine where to shade is to choose a test point that is very simple. I always prefer to use 0, 0. And however, if a graph goes through 0, 0, then I like to use 0, 1 or 1, 0. Something very simple, because you remember, to test a point, all you're simply doing is taking the x and the y coordinates and plugging them in for the x and y variables of your equation. And when you plug them in, if it becomes true, then you shade all the points that are below your equation. If you test it and it's false, then you're going to shade all the points on the inside. So there you go, ladies and gentlemen. That is just kind of your basic rundown of how to graph absolute value inequalities. Thanks.